Hey guys, welcome to Homework Help for Year 5, Term 4, Week 9. On page 7, it says find the sum of all the prime numbers from 30 to 50. So all the prime numbers are numbers that can only be divided by itself and 1. So let's have a look at this. So for example, 31 is a prime number. Okay, 32 is not because it can be divided by itself, 1 and itself, which is 2 factors, and it can also be divided by 4 and 8. So it's got 4 factors. Maybe it has more. It has 2 and 16 as well. So it's got multiple factors. So prime numbers can only be divided by itself, and this one is 1 and 31. So it only has to have 2 factors. If it has more than 2 factors, it's not a prime number. So we can rule out all the even numbers, because even numbers can be divided by 2, so then we don't have to worry about the even numbers. Okay, let's look at the odd numbers. 33 is an odd number, but it can be divided by 3 and 11, and so there's more than 2 factors already. 35 can be divided by 5 and 7, so no. 37 is a prime number. Alright, 38, no. 39, no. 40, no. 41, yes. Okay, 43, yes. 45, no, because 45 can be divided by 5 and 9. 47, yes, and not 49, because 49 can be divided by 7 and 5. So the only, let me just double check if I have all of them. 34, 35, 36, 37, 38, 39, 40. Yep, these are all the prime numbers. So that means this is find the sum of all the prime numbers. So you got to add 31 plus 37 plus 41 plus 43 and then plus 47. And that's your answer there. So add them all up and get the answer. Oops. Question 2. Find the sum of all the factors of 60. So you have to understand what all the factors of 60s are. So what multiplies to give us 60? What numbers? So we have 1 and 60. We got 2 and 30. We got 3 and 20. Got 4 and 15. We got 5 and 12. We got 6 and 10. 7, 8, 9. So that's it. These are all the factors of 60. It says find a sum. So what we do is we add all these numbers up. Question 3. A rectangular paddock has an area of 240 meters squared. Find the length if it is 8 meters longer than the breadth. Okay. So this has an area of 240 meters squared. Now, the breadth is this one, and the length is this one. So length times breadth should equal to 240, but the length is 8 meters longer, so we got to use guess and check. Okay, so let's look at 240. What numbers multiply to 240? Well, we got 24 and 10. Now, is 24 8 more than 10? No, it's 14 more than 10, so we can't use 24 and 10. Okay, what else can we do? Can we do just throw in some few numbers? We can do maybe 2 and 120. Is 120 8 more than 2? That's a no as well. How about try 12 and 20? 12 and 20 gives you 240, but is 28 more than 12? Yes, it is. So therefore, these are the numbers. We got 20 here, and whoops, rubber is a bit too big there. And then this one must be 12. So 20 times 12 is 240, and 20 is also 8 more than 12. So that makes sense. Alright, question 4. Find the number between 0 and 100, which is odd. a multiple of 3 and whose digit when multiplied equals 18. So we have a bunch of conditions. First, they have to be between 1 and 100. Then they have to be odd. Then they have to be divisible by 3. That's what multiple of 3 means. Then the digits have to multiply to 18. Okay, so let's just look at which one is the most important one out of all these 4. I would say this one here. This one will rule out a lot of numbers. 1 to 100, that could be anything. Odd, there's like 50 odd numbers. Divisible by 3 makes it a bit easier. So divisible by 3, there's 33 numbers. But this one can only a few numbers can multiply to 18. So we're going to choose this one because it's going to help us eliminate most of the numbers and narrow it down. Okay, so let's imagine we got two digits. Okay, so it says the digits must multiply to 18. So let's look at 18 for a second. 18. What are the factors of 18? Well, there's 1 times 18. There is 2 times 9. There is 3 times 6. And 4, 5. Yeah, that's it. These are the factors. So you could have, so what I'm going to write here is 18 can be written as, so 18 can be 1 times 18, 2 times 9, or 3 times 6. Alright. So now, what we're going to do is we can have these in here. So can we have 1 and 18 here? No, because if you have 1 and 18, this is a 3-digit number, and it says it's a 2-digit number. Find the numbers, oh, well actually, it doesn't say it's the 2-digit, but because it's between 0 and 100, it has to be 2-digit. It can't be 3-digit. Okay, so 1 and 18, not going to work. So let's rub that out. Oops. Okay, so that's ruled out. 2 and 9, we can do 2 and 9, yes. So the digits we can have is either 2 and 9 or 9 and 2. These are the possible ways, okay? So we could have the number 92 or 29, because the 2 and 9 will multiply to 18. But now let's see if these two numbers satisfy these four conditions. So satisfy the fourth condition, yes. Is it divisible by 3? Well, looks to me like none of these are divisible by 3. You can try it and you'll see. So these, they're not going to work. They can't be divisible by 3. So therefore, we can't choose 2 and 9 or 9 and 2. Now we got one more left, which is 3 and 6. So let me just rub this out. Okay, so we could have either 3 and 6 or 6 and 3. These digits multiply to 18. So 63 or 36. Now, let's look at 36. Can we choose 36? This one, is it between 0 and 100? Yes. Is it an odd number? No. Is it divisible by 3? Yes. And it's also the digits multiplied to 18. So this one, it's not an odd number, so we can't choose it. But now let's look at the other one. 63. 63 is between 0 and 100. Yes. Is it odd? Yes. Is it divisible by 3? Yes. And is the digits multiplied to 18? Yes. So therefore the answer is 63. Because it satisfies all of the 4 conditions. Alright, next one. Find the smallest number in which is greater than 2000, a squared number, and a multiple of 14. So you gotta think of a squared number that's bigger than 2000. So I'll just give you a little clue. 44. What you're gonna do is you're gonna do this. You're gonna do the square root of 2000. Okay. Now you might need a calculator for that, but really that's gonna give you 44 point something. So that means this. 44 squared. What's that going to give us? It's going to give you 1936. Now it says a squared number that's bigger than 2000. So we're going to need to find a number that's a squared number. So let's go through all of these. 45, 46. So 45 squared, 46 squared, and 47 squared. maybe even 48 squared. Let's see which one of these will satisfy the condition. So we're gonna look at all the squared numbers. So 45 squared is gonna give you 2025. 46 squared is gonna give you 2116, and 47 squared is gonna give you 2209, and 48 squared is gonna give you 2304. Okay, so the condition is that it has to be a squared number. Yes, these are squared numbers, and it has to be greater than 2000. So that means we can't choose this one. That one's out of the question. The other ones are above 2000, so that meets that condition. And it has to be a multiple of 4, so it has to be divisible by 4. So the way we find out whether a number is divisible by 4 is you look at the last 2 digits. These are the rules, okay? The last digit. If the last 2 digit is divisible by 4, then the whole number is divisible by 4. So 25 cannot be divided by 4, so no, this whole number cannot be divided by 4. The next one is 16. Yes, 16 is divided by divisible by 4. Therefore, the whole number 2116 is also divisible by 4. So we choose this number because it's a square number. It's larger than 2000 and it's divisible by 4. So there's your answer. Now question 6. How many common multiples of 3, 5 and 7 are there between 1 and 5000? Okay, so what you got to do is you got to find the lowest common multiple of 3, 5 and 7. Now another way to think about this, let's pretend we have 0 to 20. So actually let's just not 1 to 20. 1, 2, 3. Let's just make it 16. Alright. Now if I ask you how many numbers are divisible by let's say 2 and 3. Okay, how many numbers are divisible by 2 and 3 between 1 and 16? So you have to be divisible by 2 and 3. So what you're going to do is when you have a question like that, you have to find the lowest common multiple of 2 and 3. I'm just giving you a different question to show you how this works. Okay, so the lowest common multiple of 2 and 3 is 6. We know that. Now if I ask you how many numbers are divisible by 2 and 3 between 1 and 16, you just have to find out how many 6's are gonna be in here. There's only 2, 6 and 12. So therefore only 2 numbers that is gonna be divisible by 2 and 3. And it's going to be 6 and 12. So therefore we have 6 and 12. So what we're going to do is between 16, you take 16 because it's from 1 to 16, right? You divide it by 6. You see how many 6's go into 16, and you know that there's going to be 2 and what is it? Remainder 4 over 6. We don't care about the remainder. We only care about the number here 2. There's going to be 2 numbers. Okay. So we're going to use the same method to do this question, with the bigger numbers. So let's rub this out for us now. So to find how many numbers that are divisible by 3, 5 and 7 between 1 and 5000, you're going to do the LCM of 3, 5 and 7. So this one is going to be 3 times 5 is 15. 15 times 7 is, let me see, 15 times 7 is 105. So now we found out the LCM of 3, 5 and 7 is 105. Now how many 105s are there between 1 and 5000? So you take 5000 and you divide it by 105. And let's see, 5000 divided by 105 will give us 47, just use a calculator for this, 47.619. Okay, so that means that we're only interested in the 47. We don't care about the extra, because if anything extra will go over 5000. Okay, so what I mean by that is that there's 47 lots of 105 between 1 and 5000. If you try 48, Okay, there's 48 times 105 will give you times 105 will give you 5,040. So that's too much. See, you only want between 1 and 5,000. This 48 is too much. That means we have to choose 47. So between 1 and 5,000, there should only be 47. Okay, there's your answer. Now a lot of these questions are pretty hard, so I might just give you the answer for some of them. Next one says, what is the fraction between 6 over 7 and 7 over 9? Okay, so let me think. Now these fractions have different denominators, so it's hard to compare them. Okay, so let's make them the same denominator. So you got 6 over 7 and 7 over 9. Let's make them into, now let's find the lowest common multiple of 7 and 9, that'll be 63. So let's make it into 63, this one. So it'll be out of 63, and this one also be out of 63. Okay, so we're going to time this by 9 and time this by 9. So 9 times 6 is 54. Time this one by 7, time this one by 7, this will be 49. So the question is, what fraction, is between these two fractions? See, now it's easy to compare them. They both have a common denominator of 63. So what I'm going to do is I'm going to move these around. Okay, so what number is between 49 out of 63 and 54 out of 63? So okay, so let's just rub all that out. So between these two, what number should fit in here, which has a numerator of 13? So we want a numerator of 13. 13 out of something. Alright, well, let's think about this for a second. We want the bottom number. Well, we know the top number can't be 13 because 13 is not between 49 and 54. And also we want the bottom number to be 63 as well. Well, let's just look at 13. Let's look at the multiples of 13. Okay, so we got 13, 26, 39, 54. Wait, sorry, 52, not 54. And then 65. So which number can I choose to go into here? That's between 49 and 54. Well, I have to choose 52. 52. Okay, so I want, okay, because I can simplify this into something with 13. I can divide this by 4 and get 13. And I can divide this by 4 as well and get some number down the bottom. Because we can simplify that, okay? So we can get a number with a 13 on top as long as we can simplify it. But the way to simplify is this number has to be a what do you call it? A multiple of 13. So let me think. Now I want this number to be 52 out of 63 because that's the best way to compare these kinds of fractions. Okay. You can see this is 49, this is 52, and this is 54. So this one is between 49 and 54, which is great. And these are all 63 as well, which is now we can compare them, right? If there were different denominators, then we can't compare them. But now they're good. Now this number we know is between this one and this one, so that's good. Now the problem is 52 out of 63. If I divide it by, I want to get into 13 here for the numerator. So I need to divide this by 4 and I need to divide this one by 4. Now, what should the bottom number be? Well, let's divide 63 by 4. How many 4s in 63? Well, divide it. We got 63 divided by 4. This would be 1. 1 times 4 is 4. Minus would be 23. 23 divided by 4 is 5. And you have 20, remainder 3. So if I divide it by 4, if I divide 63 by 4 using fraction method, I'm gonna get 15 3/4. This is changing from improper to mixed numeral. Okay, that's So I can divide it like this. So therefore, I should have now. This one is going to be 15.75. That's another from fraction to decimal. So I can write here is 15.75. Now, you have a bunch of answers here. So let's just go through the answers here. Let's have a look. So we have 13 on 16, 13 on 15, 13 on 17. So you got. So let me just rub this out. So I've got 13 on, well, the last one can't be, okay? The last one, I'm not going to include it because the numerator is 16 and they want a numerator of 13. So the last one is really wrong there, so we can't choose that. So we can have 13 on 16, whoops, 15, 13 on 16 and 13 on 17. Now this number 13 on 15.75, which one is it closest to? Is it closer to 15, 16 or 17? Well, it's not close to 17, okay? It's kind of between 15 and 16, right? But it's 0.75 is closer to 16, so therefore we choose this answer here. This is the closest answer to what we got, so therefore that's the answer there. And that's the correct answer. Now number 8. A rectangular piece of paper has sides 48 and 60 centimeters. I've just drawn it there. If equal squares as large as possible are formed inside this rectangle without any gaps, what's the minimum amount? Okay, so to form squares, we need to divide 48 by, let me see, 48 by a certain number and 60 by a certain number. And we want the highest number. So what we're doing is we're looking for the highest common factor of 48 and 60. 48 and 60, I can think of the highest number will be 12. So 48 divided by 12, you're going to get 4. So 1, 2, 3, 4. And 60 divided by 12, I'm going to get 5. So hopefully I can draw this right. 1, 2, something like that, okay? So each one of these will be 12 and this will be 12, and that's a square, as you can see. So square is 12 by 12. And the number 12 fits into 48 perfectly. Okay, so 12, 12, 12, 12. Alright. And here you can have another one. You can have 12 as well. Goes into 60 5 times. So there's gonna be five lots of squares there, and there's gonna be 4 lots of squares there. So how many squares can I have in there? You got 4 lots of squares times 5 lots of squares. That's 20 squares. If you just, or you can just draw all the squares and count them if you want. Okay. There's 20 squares there. 4 times 5 is 20, so the answer is A. Next one, trees are to be planted equal distance apart, surrounding a rectangular field with sides 12 meters by 16 meters. If a tree is definitely planted at each corner, what is the least number of trees planted? Alright, the least number of trees. So we gotta look at 12 and 16, and we gotta find the highest common factor. So HCF of 12 and 16 is equal to what? 4. We want them to be equal distance apart, right? So we gotta have 4, which means it's gonna be 3. It's gonna be 4 here, 4 here, and 4 here. That makes 12, right? And for 16, I have to divide 16 by 4. I'm gonna get 4. So actually I didn't do it right there. Hold on. This will be 4, 4, 4, and 4. You can see it's 16 there. So how many trees we got? Well, I'm going to put all the dots in and you can just count them yourself. All you gotta do is count all the dots and there's your answer. Question 10. 70 tiles, each measures 3 by 2. What is the area of the largest possible square using these tiles? Okay, so if you have a 3 by 2, so imagine you have a, like this. Actually, let me just draw smaller. So 3 by 2 looks kind of like this. Now first we have to figure out how do we make a square out of this. If I was to combine two of these blocks, 3 by 2, this is 3, this is 3, this is 2. Okay, and I have to do another one here. That's 2. Okay, this is still not a square yet, so let's make more and see what we get. Now this is so the top one is 6 and the side one is also 6. This is a square, 6 by 6. Okay, so to make a square, to make one square, you need 6 of them. So to make one square, we need 6. Now let's see, what is the largest area of the largest possible square using these largest possible area? Okay, so what we're gonna do is to make another square, you're gonna need another 6. To make one square is 6. Okay, another square you need another 6. So that means to make square, but then this is not a square. Okay, so just remember that one square is a 6 by 6. Now, how many, if I want to make another square out of this, I need a, let's call this one square. I'm going to need 4 squares to make another square here. Okay, so next one, so the first one you can have is either 6. The next one you can have is, you got 4 lots of 6, so 24. The next one, if you want to make another square, you're going to need, so you got a 3 here and a 3 here. To make another square, you need 9 of these squares. So you got 9, right? 1, 2, 3, all the way up to 9. And each square, remember, each of these squares are 6. There's 6 blocks. 6 of these 3 by 2s. Every time you want to make a square, you can only go either one of these, or you can have 4 of them, or you can have 9 of them to make squares. Okay, so if you have 9 times 6 is 36. It says what is the largest possible. Alright, so I'm gonna rub this out in order to show you. So it looks to me like this. This is what's happening. This is 1 times 6. This is 4 times 6. This is 9 times 6. Can you see that these are square numbers? 1, 4, and 9. So the next one, if you want another square, you're going to have to do 16 times 6. And then 25 times 6. So the question is, what is the area of the largest possible square? So the area of the square. Okay. So let's see, first one is 6. Okay, so that's 6 times 6, that's 36. That's the area of this one here. Oops, let me just. So the area of this one is 36. The area of this one, which is, let me see. You had 4 blocks, right? Each one is 6 by 6, so that's 6. So that means this is 12 times 12. That'll be 144. Okay. So this one will be 144. Now, if you have 3 by 3 block, so this is a 3 by 3 block here. Each one is 6 by 6. This will be 18 times 18. So 18 times 18, we get what? 8 times 8 is 64. 8 times 6 is 8 times 1 is 8 plus 6 is 14. 0. And then you have 18, so this will be 4, this will be 2, this will be 324. Okay, so it looks to me like 324 is the biggest at the moment. Let's try the next one. So if you have this, you have 324. Now let's try 16 by 16. Okay, so 9, so that's hold on, this is, sorry, that was not 16 by 16, sorry, 4 by 4, so 4 by 4. Now each one is 6, so this will be 6, so this will be 24 times 24. Okay, there's 24 there, so let's do that. 4 times 4 is 16, 4 times 2 is 8, plus 1 is 9, magical 0, this will be 8, and this will be a 4, so it'll be 6, 9 plus 8 is 17, and this will be 5, so this one will give you 576 blocks, sorry, not blocks, the area. So that means out of all of this, you can make this one. This one is gonna work. 576. All of these numbers are numbers that you can make squares with. Okay, all of them. That one, that one, that one, that one. Okay, and 576 is just the highest one that they gave us, so therefore that's the answer. If let's say they change this answer to actually let's say they change this answer. Let's say they change the answer to 580. Then you can't choose it because these are the only numbers that will give you the largest square. To make a square, you need these numbers. Right? These are the areas of the squares. So these are the only numbers we can use. So if it was 580, you would discard it and just choose the next one, the next highest one, which is 324. But in this case, 576 happens to be also the numbers that work, so therefore 576 is the answer. Alright, next one. Now we got 12 chickens and we have 12 chickens and rabbits. So there's 12 animals. They have 40 legs altogether. How many chickens are there? So you got to use guess and check. So I could just say if there's 12 animals, maybe we can have 6 and 6. Can that work? 6 rabbits. Each rabbit has 4 legs. So together, all 6 rabbits should have 24 legs. So 4 times 6 is 24. Chickens have 2 legs each. So if you have 6 chickens, you got 6 times 2 is... Whoop, 6 times 2 is 12. 12 plus 24 is 36, so that doesn't work with all the legs. There's 40 legs altogether, but if you do this, you only have 36 legs. So you gotta do guess and check and figure out the rest. Okay, so that's not gonna work. Okay, I'll leave that to you. Question number 2. In the pattern, what is the 18th number? Well, okay, there's 2 ways to do this. Now there's how many numbers are this? Is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is the 12th number. And if you notice it, it'll be a repeat of the first 4. Just the first 4 numbers just gets on repeat. So the 18th number, so what we do is we take 18, we know there's 18 numbers, we divide it by 4 and we get what? 4 remainder 2. So what happens is this. Let me just write it out for you so you see what's happening. You got the first 4, then you got the second lot of 4, the third one, then the fourth one will be 1, 3, 5, 8. So I'm gonna put 18 divided by 4, which gives me 4 remainder 2. Okay, and then so that's another 4. Then I'm gonna have 1, 3, 5, 8. So let's look at the 18th number. Is the first number, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the 18th number is 3. Can you see that when you divide 18 by 4, you're gonna get 4 groups. You get 1, 1, 2, 3, 4. Remainder 2 means that the remainder 1 is here, remainder 2 is here, remainder 3 is here, and then remainder nothing, remainder 0 will be here. Remainder 1, remainder 2, remainder 3, remainder 0. Okay? Because this is the 20th number. If you divide 20 divided by 4, you get no remainders. Anytime there's no remainders, it's always going to be an 8. Anytime there's one remainder, it's always going to be a 1. Anytime there's 2 remainder, it's always going to be a 3. So therefore the answer, the 18th number must be 3, because it's a second remainder. Okay. Question 3. 6 boys stand in a line. How many ways can they stand? Well, 6 boys stand in a line. So imagine you got, this is your line. There's 6 boys. So how many people can stand in the first position? Well, there's 6. Okay, how many people can stand in the second position? There's 5. Because once one person stands in the first position, there's only 5 to choose from for the second position. And then 4, 3, 2, 1. What do we do with these numbers? Just times them up and get the answer. Excuse me. Question 4. For every $2 Anna receives, Jenny gets $3. Okay, so imagine you have Anna and Jenny here, and let's say the total. So if Anna has $2, Jenny should get $3, and the total will be $5 to have altogether. If Anna has $4, then Jenny should have $6, and then together they have $10. If Anna has $6, Jenny should have $9, and together they have $15. If Anna has $8, Jenny should have what? $12, and together they have $20. Okay. Every time Anna gets $2, Jenny gets $3. That's what the question is saying. So she gets 2, she gets 3. Okay. Now, do you see a pattern here? You got 5, 10, 15, 20. And it says that we want to have 60. Together they have 60. So we got to go all the way to 60. So we got here, we got 25, 30, 35, 40, 45, 50, 55, and 60. Now it says, how can you divide 60 between the two girls? So that means what number should Anna get and what number should Jenny get to make a total of 60? Well, let's have a look. So can you see the pattern? 2, 4, 6, 8. This one must be 10. This one must be what? 12, 14, 16, 18, 20, 22. This must be 24. Okay, and this one is going up by 3, 6, 9, 12. Okay, so you can think of it as these are multiples of 3 and these are multiples of 2. So multiples of 2, you got, so this is 1, 2, 3. Now this is multiples of 5. So to go from 5 to 60, this is 5 times 12, isn't it? And this is 2 times 12. This must be 3 times 12 because there's 12 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so you 12 times 3, this should be 36. 12 times 2 should be 24, and you can see that 36 plus 24 is indeed 60. So you can take 60 and divide it into the two girls, and Anna should get $24 and Jenny should get 36. So that's a long, complicated question. So that's the idea of the question, and it's basically rates and ratios when you learn higher level mathematics. The topic for that is rates and ratios. So 60, Anna should get $24 and Jenny should get $36, and there's your answer. Okay, at question 5, at a party, 2 guests shake hands exactly once with each other. How many handshakes are there among 8 people? So to do this question, there's a formula. The number of handshake is equal to the number of people multiply with the number of people minus 1. So then you multiply the number of people times it by that number minus 1, and then you divide it by 2. Okay. So because imagine if you have A, he's gonna handshake with how many people here? A is gonna handshake with B, C. How many people we got? 1, 2, 3, 4, 5, 6, 7, 8. Yep. B, C, D, E, F, G, H. See? So there's gonna be there's gonna be 8 people multiply with 7 people, because each person can only handshake 7 people, right? So that's 8 times it by 8 minus 1, which is 7, and then we divide it by 2. Like I said, we divide it by 2 because there's been double count. For example, A handshakes with H, and then later on you're gonna have H handshake with A again. So that's the same thing. A and H has handshake only once. Okay, so divide by 2. There's been double counts here. This one, A handshake with H, is the same as H handshake with A. This is the same thing. So we have to divide it by 2. It doesn't count as 2, it counts only as 1. So this will be 56 divided by 2, and you can work out the answer to that. Now question 6, Janice wants to gift wrap the cube with side 5 centimeters. How many gift wrap will she need? So because we're gift wrapping this, we're wrapping the outside. Okay, we're wrapping the outside of it. We're not looking for the volume, we're looking for the surface area. So the question really is find the surface area of this cube. Now the surface area is just the area of all the surfaces add together. What is the surface of, let's say, the front face? The front face is 5 times 5. The area of that face is 25 centimeters squared. The top face is also 25 because you got another 5 times 5. Side is 5 times 5 again, which is 25. So just do 5 times 5 will give you 25. So we do 5 times 5 equals 25. This is one face. This is one face. Now the cube has 6 identical faces, so we times this one by 6 to get all the faces of a cube, and there's your answer. So multiply 25 by 6 and get the answer there. Question 7, how far will the car travel 54 kilometers, so 54 kilometers in 1 hour? 1 hour. Now the question is, how far will it travel in 3.5 hours? So to go from here to here, you just times it by 3.5, so you're going to times it by 3.5 as well. Or you can think of it this way. Let me just... 3 hours... Sorry, 1 hour is 54 kilometers. How many is 3 hours? 3 hours is 54 times 3. 4 times 3 is 12. 15, 16, 162. Okay, so 3 hours is 162. Now we want 3.5 hours. So let's find out what half an hour is. So 1 hour is that. Half an hour must be half of 54, which is 27. So 3.5 hours. Whoops. 3.5 hours must be 162, which is 3 hours, plus with the 27, which is the half an hour. Add it together and get the answer. Okay, next question, question 8. It says find the area and the perimeter. So the area, let's just cut it into 2 pieces here. This will be, this top piece is 3 times 17. So this one is 3 times 17. Get the answer there. Now the bottom one, is, you got 9 times, now we need this length here. This is the width of the rectangle. So we have here is 17, we have here is 15. 17 take away 15, then that one, okay, this one, whoops. This one, 17 take away 15 must be 2, so this one must be 2. Alright, so that means this will be 9 times 2. get those two numbers, add them up and get the area. The perimeter, okay, perimeter. The perimeter is 3. The perimeter is 3 plus 17 plus with, how long is this thing? This is 9. From here to here is 9. Here is 3, so that must be 12. So this must be 12 here. So plus with 12. Plus with, we said that was 2. So plus 2. Plus with 9. Plus with 15. Add them all up, get the perimeter. Question 1, multiple choice question. A racing car driver was traveling distance a football field each second. If a football field is 100 meters long, how fast was this person driving in kilometers per hour? Round off to the nearest. Okay, so that means that, I'll write this out. So what does that mean? So in 1 second, this person is traveling 100 meters because he's traveling a distance of football field each second. A football field is 100 meters, so he's traveling 100 meters in 1 second. Now the question is, how fast is this person driving kilometers per hour? So we want to get to 1 hour. We want to see how far he's going to go in 1 hour. So from seconds to hour, we times it by 3,600. So this one, you times it by 3,600. So that will be what? 3600 times it by 100, put another 2 zeros there. That's in meters. Converted to kilometers is 360 kilometers. Okay. Now it says find the sum of 3% of 5 and 90% of 4. Huh. Okay, so now these are in meters, so let's change it to centimeters. Okay, otherwise you're gonna get decimals. I don't like to deal with decimals, so let's change it to, this will be 500 centimeters, and this is 400 centimeters. So all we gotta do is find 3% of 500, and we're gonna add it with 19% of 400. Whatever that is, get these two numbers and add them up, get the answer. Now if you're not sure how to do 3% of 500, I'll show you. 3% of 500. Now to do this, you got to change this one into a fraction. 3% is 3 over 100. The word of means times, and 500 is a whole number, so 500 over 1. Now when it comes to multiplication, if you still remember, we can simplify this. We can just cross out the zeros from the top and the zeros from the bottom, and then we can just multiply. 3 times 5 is 15, so the first one is 15. So 3% of 500 is 15. Now 90% of 400, okay, I'll do that over here as well. 19% of 400. 90%, you gotta change it to a fraction, which is 19 over 100. Of means times, 400 is 400 over 1. Now we can cross it out, so 2 cross the zeros from the top, 3 zeros from the bottom, and you're gonna get what? 19 times 4, 20 times 4 is 80, 19 times 4 must be 76 over 1, which is 76. So this is 76. Add them together, you get the answer. Okay. Next one, I'm going to go through question 3. Last exam, I scored 12 above average. This time, I scored 8 below average. Both averages were the same, so the difference in my 2 marks are what? Okay, so imagine you have, how do I draw this? 12 above average. So imagine you have an average of a bunch of numbers, okay? Actually, so here's the average, and in the first time you scored 12 above average. Whoops. So you're up here, you're 12 above the average. And then in the second one, you score 8 below the average. So you're 8 here. The distance from the average to the second score is 8. Both averages are the same, so the difference in the 2 marks must be, so you got 12. The difference is basically the distance between the 2 marks. Okay, how far is the 2 marks apart? So to find the distance of the 2 marks, we just take 12 plus 8. Because we got whatever amount here and here, if you do this, take away this, you're gonna get this distance here, which is 20. Okay, 12 plus 8 is equal to 20. And so the answer is D, if that makes sense. Question 4. Today the sum of age. Oh, okay, I think it's left out my age. The sum of my age and my son's age is 52. 4 years ago, I was 3 times as old as he was. In how many years will he be twice as... okay, so 3 years ago. So this is a guess and check kind of question. So you got to think, okay, 3 years ago, you were 3 times... I'm going to rub out this one here. 4 years ago, you were 3 times as old as him. So that's 4 years ago. Let's see. So let's try 3 times as old. So maybe try 10 and 30. See, this is 3 times more, right? This is my age and this is my son's age. So just guess 2 numbers. One of them is 3 times the other. Okay, and it says 4 years ago. So this is 4 years ago. 4 years ago. That means 4 years later, you're gonna be 34, and this person's gonna be 14, right? And then you add these two together to see what we get. It has to add up to 52. Because right now, my age and my son's age is 52 right now. Okay, so let's see. Do these add to 52? We get 48. No, close, but no. So we can't choose these 2 numbers. So instead, let's increase it. So instead of that, I'm going to do 11 and 33. Okay, let's add 4 to these 2 numbers. Add 4 to this, add 4 to this, and you're going to get 15 and what's this one here? 37. Okay, do these add up to 52? Yeah, they do. So therefore, right now you're 37 years old and the other one is 15 years old. So that means that, so we just guessed it. 37 years old for the man, and for his son is 15 years old. And it says, okay, 4 years ago I was 3 times as older as he was. So see, look, 4 years ago, right? You were 3 times older. You were 33, he was 11, and you were 3 times older. So that makes sense. Now it says, in how many years will I be twice as old as he is? In how many years? Okay, so right now, let's remember that your age is 37 and his age is 15. Okay, so 37, 15. Let's just keep that in memory for a little second, and I'll write out the next part. So I'm going to write it over here. So you're 37. Actually, it's hard to see there, so I'll write it over here. 37 and 15 right now. Now it says, in how many years will I be twice as old as he is? Well, just add them up. So this next year you'll be 38 and he'll be 16. Is that twice? No, let's keep going. 39, 40, 41, 42, 43, 44. Let's just stop there for now. And this will be 17, 18, 19, 20, 21, 22. So when is it that you're twice as old as your son? Well, looks to me like this one here. And it says in how many years will that occur? Well, 1, 2, 3, 4, 5, 6, 7 more years for that to happen. So if you look at the answers here, we know that it's going to take 7 years, right? So that means that there's none of these are the answers. 8, 9, and 10, none of them. So therefore the answer is D. Question 5. how many boxes measuring 2 meters by 3 meters by 4 meters could be stacked within a room measuring 8 by 9 by 15? Okay, so the best way to do this is to see how are we gonna divide, how are we gonna fit all the boxes tightly into this bigger box, the small box. So how many of the small boxes can fit into the big box, nice and even? Okay, so I've put the 2 by 3 by 4 to look like this, and the 8 by 9 by 15 to look like this, because you can see that 3 can go into 15 like 5 times, so it fits perfectly with no gaps, and you can see that 2 can fit with the 8 perfectly as well with no gaps. Okay, now so that means, and then 4 doesn't really fit nice and tight with the 9, so there's going to be a little gap at the top here, but it can't be helped because you can't put more, you can't really break these boxes up and then try and fit it on the top. It doesn't work that way. So how many of these boxes can go in? Well, we know there's 15 divided by 3, there's 5 of them, so 5 boxes can go at the bottom here, and then 8 divided by 2 will give you 4, so we can fit 4 this way. Okay, and how many upwards? You can 9 divided by 4 is 2, so we can only fit 2 up here. So I should have drawn it like this, like this. So 4 this way, and 5 this way. Okay, and then we got 2 lots of them, 2 layers. So how many you got? Okay, so let's count it. We got 5 here, we got 4 here and 2 here. So 5 times 4 times 2. So 5 times 4 times 2. 5 times 4 is 20. 20 times 2 is 40. So you can only fit 40 into here. Yes, there will be some leftover gaps, but there's nothing we can do about it because these boxes are that size. Alright. Okay, next question. Now it says we got to do this one, so let's look at the clues. It says I've written down all of the boys and girls' names there. Okay, so the first clue says Stacy will get her dad to help, and together they plan on planting more than the girls planting flowering crabs. So we got some numbers here. So more than the girl. Okay, so Stacy is a girl, and she will get her dad to help her, and together they plan on planting more than the girl planting flowering crab. So then that means that the girl planting the flowering crab must be Courtney because she's the only other girl. Okay, and the boy with the oak, but fewer trees than Gregory. So we got Stacy. She's gonna be more than someone. They're gonna plant more than the girl and the boy, but less than one of the but fewer than Gregory. So Gregory is more than her. So Gregory is more than her. So Gregory should be 20, and Stacy should be 4. But you can see that Stacy is kind of in second place. According to this clue, she has the second highest amount of trees. I think they're planting trees or something, right? Yeah. Because it says she's more than 2 people. She's more than 2 people, but less than 1 person. She must be in second place. So she must be the one with the 4. And then the person who's in the first place is more than her, and that says Gregory. Fewer trees than Gregory. So Gregory must have the highest trees. Now the next clue says Courtney will plant fewer than Gregory. Okay, Courtney will plant fewer than Gregory. So that means that Courtney must be 2 and fewer than Gregory. So that's she's already fewer than Gregory. We know that. Fewer than Gregory, and the girl planting red buds. Yes, we know that already. But more than the boy planting oak. So she's got more than the other boy, so that means that Courtney must be 3 and the Evan must be 2. Now it says more than the boy planting oak. That means the boy planting oak must be Evans. Okay, and it says Courtney will plant fewer than Gregory and the girl plant. Okay, so that's, we only need one more clue. Now it says Stacy will get, so let's look at the first clue again. Stacy will get her dad to help her and together they plan on planting more than the girl planting flowering crab, we know that. And the boy with oak. So the boy with oak must be Evans because there's only 2 boys and the first one has oak and the second one is Gregory. So therefore the first boy must be Evans and he must be the one with the oak. Yes, so we got that already. So hold on. Flowering crab, the boy with the oak. Oh, whoops, I looked at the wrong clue. I was supposed to look at the second clue. Okay. Courtney will plant fewer than Gregory and the girl planting red bud. So Courtney is a girl and the other girl that planted red bud must be Stacy. So Stacy must be the one with the red bud. And the white pine must belong to Gregory because that's the only one left. So there's the answer there. Next one is, okay, we got this one here. Let's just look at, I've written down all the boys and girls. Looks to me like David and John is the only boy there. Now the clue says Brianna, Angela, Jenny. Okay, so Brianna, Angela, Jenny. So Brianna, Angela, and Jenny. The boy who unplugged the coffee pot. So the person who unplugged the coffee pot must be a boy. So it's either the coffee pot, where is it? Okay. So that means it can't be any of these guys. We can cross them out. They can't be the one to unplug the coffee pot. Oh, whoops. Sorry, that's wrong. The coffee pot, like that. Okay. And then it says the girl who forwards the phone. So who's the girl that forwards the phone? Well, that must be Lisa because she's the only other girl left. We already mentioned Brianna, Angela, and Jenny. So then there's only one girl left, which is Lisa. It says, and that's the one that's the girl who forwards the phone. So then for Lisa, where is the forward the phone? Therefore, this Lisa must be the phone. And the boy who stores information on the computer. Okay, so that means that Lisa, once we tick Lisa, we can cross out anything else for Lisa. And we can also cross out the top here. All of these guys can't be the phone. Okay, and the boy who stores information on the computer. So therefore, these 3 cannot be the computer because we know it's a boy that's doing the computer thing. Okay. Now next one says David, Lisa, and John. Okay, let me just redo that. David, Lisa, and John. The girl who locks the door. Okay, so it can't be these people that lock the door, so they can't be door. What else? Let me just do something here to make it easier to see. Okay. Now it says David, Lisa, John, the girl who locks the door, and the girl who locks the files. Okay, so the girl who locks the files. So they also can't be David, Lisa, and John. What else? And the girl who turns off the copier, so they also can't be the one who turns off the copiers. So we cross it out. Okay. All share responsibilities in the office. That's fine. Next is David. So let's use the next clue. It says David, Angela, and Jenny. The boy who stores information. Well, there's only one other boy, and that's John, and he must be the one that stores information on the computer. The boy who stores information on the computer. Okay, so he must be the one to the computer. So that means that John can't be the one doing the coffee, and we cross it out the David as well. Since it belongs to John now, everything else is cancelled out. Next one is and the girl who turns off the copiers. The girl who turns off the copiers. Oh, okay. So the girl who turns off the copiers. Well, it can't be Lisa because Lisa already does the phones. So the only other girl that turns off the copiers must be Brianna. So we go to copiers and we tick copiers. And then once we tick copiers, we can cross out anything else, any other person that does the copiers, and she doesn't do anything else besides the copiers. So we can cross all that out. And if you can cross all that out, you can clearly see that the person who does the coffee pot must be David. See, there's only one box left here, and everything else is crossed out. So that's David. Now between Angela and Jenny, it's just between these two that we don't know whether it's going to be which one is which. Okay, so the last clue is going to say Angela does not lock the doors. If Angela doesn't lock the doors, so where's Angela? Angela doesn't lock the doors, so that means she must be doing the files. Okay, because according to look at this one here, actually not that one. If you look at this one, so Angela can't do any of the other ones, so she must be doing the files. So therefore, we cross out her doing that, and then obviously the person who does the door must be Jenny, and there's your answer. So you can use the clues and eliminate all the possibilities that doesn't work, and then the ones that work will show up. All right, this is a very long video, by the way. Lots of pages of homework. Now this last one, oh my god. You know what, I'm gonna let you do the last one by yourself. I think that's you're gonna use the same trick. Okay, I'll help you with the first few, and that's it. Okay, so now it says Taylor and the boy who. So what you're gonna do is this. You're gonna take. Okay, so it says Taylor and the boy. So I'm gonna read it out for you. Mrs. Bishop took a group of boys on a bird scouting expedition. Each boy sighted either a killdeer, a grosbeak, a martin, a robin, a cardinal, a mockingbird, a thrasher, or a blue jay. Scout through these clues to determine which boy spotted which bird. Now the first one says Taylor and the boy who spotted. Alright, so Taylor. So once it says Taylor, it lists the first person. So we're going to look at Taylor. Okay. And the boy who spotted the grosbeak. So this is the second person. So this is a list. Says Taylor, comma, and then this is the second person. By the way, these are all boys. So I'm not going to write boys or girls for this. These are all boys. So the boy who spotted a grosbeak. That means that Taylor can't be the one that spotted the grosbeak. So we cross him out. And the boy. And the boy who sighted the cardinal, so that means Taylor can't be the one who sighted the cardinal. And the boy who saw a thrasher, so that means Taylor can't be the one who saw the thrasher. Okay, then we go into the second clue. Matthew, so we look at Matthew. He's the one that's listed first. And then the next one says, and the boy who saw the killdeer, so Matthew can't be the one who saw the killdeer, so we cross out the killdeer for Matthew. And the boy who spotted the martin, so Matthew can't be the one who spotted the martin. And the boy spying a mockingbird, so he can't be the one who saw the mockingbird. All spotted their birds in a meadow by the woods. Next one says Damon. Alright, so next one we got Damon, Perry, and Justin. They're all been listed. So Damon. So we're gonna look at this one: Damon, Perry, and Justin. Alright. The boy who saw a killdeer. So that means that this next person, the boy who it can't be these guys because they've been listed already. So then that means that Damon, Perry, and Martin cannot be the one who saw the killdeer. So we cross it out, the killdeer, for all three people. And the boy who spotted a robin. Okay, so that means these three boys cannot be the one who saw the robin as well. So cross it out for the robins. complain of being hungry long before the lunch breaks. Okay. Next one. We got Damon Cortez. So 2 boys. I'm gonna highlight them. So Damon and Cortez. Okay, and then it says the boy who found a cardinal. So that means they can't be the one to have found the cardinal. So we cross out cardinal for both of them. The one who spotted a blue jay. So they can't be the one who saw the blue jay as well. So we cross out blue jay for both of them. And the one sighting the thrasher. So they can't be the one who saw the thrasher as well. For those 2, Damon and Cortez. Alright, then it says study the nesting habits of the birds. Okay, next clue. Justin, Ty, and Dane. So I'm gonna highlight Justin, Ty, and Dane. Alright. The boy spotting a killdeer. So they can't be the one to saw the killdeer. So we cross it out. Whoops. What else? The boy who saw the grosbeak. So we gotta cross out the grosbeak for all 3 of them. The boy who spied the robin. So they can't be the one to saw the robin. What else? And the boy with the blue jay. So that means they can't be the one to have seen the blue jay. Earning points for whatever that is. Okay. Next one, question. Clue 6. Up to clue 6 now. It says Taylor. Okay, only lists one person, so Taylor. The boy who saw the killdeer. So he can't be the one to have seen the killdeer because Taylor has been listed as the first person. The second person is the one that saw the killdeer. So whoever that is. The boy who saw the marten. So Taylor can't be the one who saw the marten. The boy who saw a cardinal. So Taylor can't be the one who saw the cardinal, which we already crossed out. The boy who saw a blue jay. So Taylor can't be the one who saw the blue jay. And Perry. And Perry. Oh, so Perry is also another person that's been listed. Okay, so where's Perry? Here. So that means that Perry can't be these other boys as well. Perry can't be the boy who saw the killdeer. Okay, we cross out the killdeer for Perry. Perry can't be the boy who saw the marten. So we cross out marten for Perry. And Perry can't be the boy who saw a cardinal. So where's cardinal? Cross out cardinal for Perry as well. And the boy who saw the blue jay. So that means Perry can't be the one who saw the blue jay. Okay. Next one, it says Matthew. Okay, let's rub this out. Matthew, Perry, and Dane. So I'm going to highlight them. Matthew, Perry, and Dane. Okay, the boy sighting the mockingbird. So they can't be the one who saw the mockingbird. Where's the mockingbird? Here. So I'm going to cross out mockingbird for Perry and Dane because Matthew's already crossed out for mockingbird. So that's that one. The boy who spotted the grosbeak. So they can't be the one who saw the grosbeak. So we cross out grosbeak for Matthew, Perry, and Dane. Dane's already crossed out. Careful to avoid disturbing the bird's nest. Okay, last clue. Last clue says Dane and Ty. So let's just rub this out. Dane and Ty. So Dane, so Ty and Dane, these 2 people. And the boy who spotted a marten. So the boy who spotted a marten. So they can't be the people who saw the marten. Whoops. Building a bird's nest. Alright, from here we can use this. That's all the clues. Okay, so now we can use this to find anything that's been eliminated and reveal the answer. So if you look at the killdeer, right? Everyone's been crossed out except for Cortez. So that means Cortez must be the one to saw the killdeer. So we put a tick there. Now if we tick that, that means that Cortez did not see the grosbeak, the marten, the robin, and everything else there. Okay, and you can see there's another one. You can see the blue jay here, the blue jay. Okay, everything's been crossed out except for Matthew, so that means Matthew must be the one to saw the blue jay. If you tick Matthew, then that means everything else does not belong to him. So we cross out the robin, the cardinal, and the thrasher for Matthew. And you just keep going until you find anything that cancels out. So let's have a look at another one. You can see the grosbeak. Everything's been crossed out except for Damon. So that means Damon must be the one who saw the grosbeak. And if Damon saw the grosbeak, then that means we can cross out anything that's not for him. So we can cross out these two. And then you can see that after we cross it out, you can see Martin, the Martin bird, the only one that hasn't been crossed out is Justin. So we tick Justin there, and then everything else that's not Justin, we cross it out. What else? Ah, yes. Now if you look at this one here, Perry, right? You can see Perry. Perry is the one that doesn't. Everything's been crossed out for Perry except for the thrasher. So that means that Perry, thrasher must be for Perry. So we crossed out everything that's not the thrasher. Thrasher can't be for the other two, Die and Tane. So we cross it out. And now once you cross it out, it eliminates everything. And look at Dane. Dane only has one left. So that means he's the one that saw the cardinal. So if he saw the cardinal, then we crossed out the cardinal for Ty. And now you can see that Ty can only have what? The mockingbird, because that's the only one left for him. If that's the case, then we cross out the mockingbird for Taylor. And then obviously Taylor is the only last one left, so that's the robin. Okay? So put all of that into the table. I actually helped you the whole thing, even though I said I was only help you a little bit, but it's okay. Just put that into the table and you're done. Hope that helps.